So in this video, we're gonna run chi-squared test of independence using the TI-84. Alright, so we are giving 200 individuals, and in this table we are having numbers that express their living arrangement versus the gender, man or woman, right? So living arrangement, they are this here, the columns, and the rows express the man and woman, so the man and woman, right? So in statistics we call them factor 1, and this one is factor 2. All right, and the test that we're gonna run, we're gonna see whether these two factors are dependent or independent. All right, so the first question, which is the hypothesis, and for this test of chi-squared of independence is always 80, factor 1 and factor 2 are independent, and in this case living arrangement and gender are independent. So how would the 80 are independent? On the other hand, HA, the alternative hypothesis, will be the same thing, so living are dependent, right? So this is A. For B, now we are looking for the critical value, and the critical value for this, we need a degree of freedom, or a degree of freedom for chi-squared. It can be the number of rows minus 1 times the number of columns minus 1, right? So now we can see how many columns we have here. They are exactly 4 columns, and we have only 2 rows. So whenever we plug it in, this is going to be 2 minus 1 times 4 minus 1, and this is going to be 3. So your degree of freedom is 3. As well, we need the alpha. So the alpha is given to us right here. Alpha is going to be 0.05. So what we're going to do, we're going to use chi-squared table, right? So it's right here, and we're going to look for 0.05 at the alpha. So this is the column, and then we're going to go all the way to degree 3. This is the row for degree of 3, and as you see here, both of them, they intersect this value 7.815. so here it's going to be chi-squared critical, it's going to be 7.815. all right, so we are up to C right now, and what we want to do is we want to get the chi-squared test, and if it's possible, the p-value. So this is done by the calculator, and the way to do it is you need to first enter the data into a matrix. So we're going to do second, and you can see here matrix in blue, so above the x exponents minus 1, and you get the matrix menu. So you're going to go to edit, make sure you are in A, enter, and here you're gonna ask you about the dimension. So dimension is number of rows first times the number of columns. So how many rows you have? 2, so that's gonna be 2 by 4, and once you put enter, you get a matrix 2 by 4, which is similar to this table. You just have to enter the values. So the first one is gonna be 54, enter, 5, enter, 22, enter, 19, enter, and then 53. So the entries, they are going in a row fashion way, right? Then 5, 23, 19. All right, so we are done with the entering the matrix. Now we're gonna go to stat, we're gonna go to test, we're gonna run the test of chi-squared. So if you have to scroll down all the way whenever you see chi-square test. So you are using C here, right? Chi-square test. Enter. So he's asking about the observed value, and the observed value is your matrix A that you enter the values here, right? So that's by default A. The expected value is in B. You are not supposed to enter anything. That's the output. It's gonna be called B. And finally, you're gonna calculate. So that's what we want. And once you calculate that, you're gonna get the chi-squared, that the chi-square test. It's gonna be 0.0315, and the p-value, if you want it, it's gonna be 0.998, and we can put 5 as well, right? So you see as well, degree of freedom is 3, so it's given to you automatically. All right, so make a decision. So how we make a decision? Either you compare chi-square critical with chi-squared test, or you're gonna compare the p-value over here with the alpha value. And the formula is gonna be, if p-value smaller than alpha, you reject 80. And I think this is easier. All right, so let's investigate what the p-value. P-value is going to be 0.9985. However, the alpha value is going to be 0.05. So we see this statement is wrong, right? False. So if the statement is false, what you're going to do? Do not reject 80. And that will be your D answer, right? And summarize. So E, so the conclusion, we did not reject 80, so we're gonna accept it. All right, so we're gonna end up with a conclusion leaving arrangement and gender are independent. Also here, we did not have enough evidence to support the claim. Let me remind you about the claim. The claim was HA, so we did not have enough evidence to support the claim. Now, I didn't want to leave without illustrating everything in the chart. So remember that if I have the chi-squared critical over here, this is related to the alpha value is equal to 0.05, right? So in other words, saying if I grab the alpha, or I find the chi-squared critical. So here for alpha very small, probably going to be somewhere here. All right, this area over here, this is going to be the alpha, is 0.05, and the point on the chart here, that will be the chi-squared critical, and that value is going to be equals to 7.815. If I graph chi-squared test or the p-value, they are exactly the same thing as well. So 0.03 is going to be somewhere here. So this is chi-squared test, and this is going to be the vertical line, and all the shaded area from this boundary red all the way, it will be my p-value, and it keep going all the way. So we notice here the p-value is greater than the alpha, right? And if it is the case, p-value greater, we do not reject. And the reason, because this is our threshold where the alpha ends, and if I'm going to the direction of the alpha, I reject 80. And that is not the case, because the chi-square test falls here inside do not reject zone. Okay.